First of all, I welcome all the students and the participants who are attending this live lecture. See this, in this today's live lecture, we shall study the methods of successive approximation. Actually, this is the next part of syllabus of the ordinary differential equation. In that ordinary differential equation, if the differential equation is of the form first order and first degree, which is in the general form, then solution of such a differential equation we can obtain by using the method of a successive approximation. If there is no any shortcut method or any other alternative methods we can use, then definitely at there you have to use method of a successive approximation. And generally for this method it is essential to give the initial condition. Okay, Ganesh, Kale, Rutika, Manisha, Sambhaji, Prasanna, Pooja, Saroja, Sangeeta, Sneha, सर्वांना काल मी अटेंडन्स टाकलेला आहे. जे अटेंडन्स मध्ये ॲब्सेंट आहेत त्यांनी येऊन भेटायचे. नेक्स्ट सी दिस, actually this is the last but one part of this our syllabus. Then there is only one bit remains, and that is Lipschitz condition. Okay, this is the remaining bit. Now we shall discuss this bit on tomorrow or day after tomorrow. So today we shall discuss the method of a successive approximation, theorem based on the method of a successive approximation. That means we have to discuss also the theorem based on this. याच्यावरचा सुद्धा बेस्ड थेरम आपल्याला डिस्कस करायचा आहे. ठीक आहे. सो सी दिस. हा, सर्व विद्यार्थ्यांना एक सूचना आहे, माझ्यासोबत कुणीच लिहून घ्यायचं नाही. डोंट राईट विथ मी, यू कॅन राईट दिस ऑन लेटर ऑन, because today we shall cover maximum syllabus, so we have to take thodi fastly here, so don't write with me. See this, we know that the general differential equation here, we know that the general differential equation is of the form in first order and first degree is y dash equals to f of x comma y. Y dash equals to f of x comma y. This is the general differential equation which we have studied already in the previous lecture. The first degree and first order general differential equation we can express in the form of y dash is equals to f of x comma y. Suppose this is equation number 1. We have find out the solution of this differential equation. Here we have to find out the solution of this differential equation. In this case, f is a continuous real valued function defined on some rectangle, that is x minus rectangle of the real, that is R, is such that x minus x naught, which is less than or equals to a, and y minus y naught, which is less than or equals to b, where a and b are greater than 0. Then we have to show that on some interval I containing x naught, there is a solution phi of equation 1 satisfying phi of x naught, which is equals to y0. This is the initial condition. This is the first condition. Phi of x naught is equals to y0. Okay. Now this implies that there is a several real valued differentiable function phi satisfying equation 2. So we can write, suppose this is the initial condition, that is equation satisfies at a point x0, the value of solution is denoted by y0 or f of x0. So there are several equations which satisfies the equation 2. So we can write this as y dash equals to phi dash of x is equals to f of x comma phi of x. See this, phi dash of x is equals to f of x comma phi of x for all x in I. such a function phi is called the solution of initial value problem. Such a function phi is called a solution of the initial value problem. So y dash is equals to f of x comma y having the initial value y of x naught is equals to whatever may be x naught, whatever may be y of x naught is equals to x naught, whatever may be the initial condition. Okay. The initial value problem is equivalent to CR. The initial value problem is equivalent to, we can take suppose इथं एक मिनिट, इथं y of x naught is equals to y naught करा, कारण it is the value of y. 1 minute, y of x naught is equals to y naught. Is like here y of phi of x naught is equals to y naught, that means y of x naught is equals to y naught. So in this case phi dash of f of x comma phi of x, which can be also written as phi of x naught is equals to y naught in terms of y, y dash is equals to f of x comma y, which is equals to, is having a initial condition y of x naught is equals to y naught. See this. Okay. The initial value problem is equivalent to, and the integral equation, we can represent this in the form of integration. If we take the integration of this, आता या फंक्शनचं जर इंटिग्रेशन घेतला, then what will happen, y dash चे integration at the y, which is equals to integration of this function is with respect to suppose x. So we can write x0 to x with the initial condition x0 to x f of, we are taking the integrating with respect to x. So we have substituted that in initial value x0 to x. So we can write f of t comma, we can write to y into dt, plus we have to consider the constant of integration, that is y0. So every equation, integral form of this equation 3, we can write y is equals to y0 plus integral from x0 to x f of t comma y of t dt. Okay. So this is the integral form of this, that means equation 4 is the equivalent integral form of equation 3. So the solution of this integral equation 4 on I is the real valued function which is denoted by phi of x on I, such that its solution is phi of x is equals to y0 plus integral from x0 to x f of t comma phi of t dt. Okay. That means the solution of this integral equation, the solution of this differential equation, which is equivalent to the integral equation, and the integral equation having the solution phi of x, which is equals to y0 plus integral from x0 to x phi of f of t comma phi of t dt. This is the solution. If we solve this integral, then we get the solution, and this solution will be in the approximation form. That is, the first approximation is given by x of t is equals to, now we shall discuss this later on. Okay. That means solution of equation 3 is equivalent to the solution of integral equation 4, and the solution of integral equation 4 is suppose phi of x on I, then it is the solution of this equation. Okay. Now write down the theorem. See this, there is one theorem, and that theorem is based on the successive approximation. Theorem is based on the successive approximations here, students. रचना भागवत, विनोद बोनावळे, अक्षदा, नीता पवार, योगेश घोडके, मस्के. इफ काही जर अडचण असेल तर विचारत चला. मस्के आहे का? मस्के थांबा, मी स्क्रीनशॉट घेतो, कोण आहे ते पाहता येतं. ओके. Now next, see this is a very important theorem which we have to discuss here. what is the statement of theorem? Actually this theorem is based on the successive approximation. This theorem is based on the successive approximation. That means here a function phi, what is the statement of this theorem? A function phi is a solution of the initial value problem y dash is equals to f of x comma y. Initial value problem means its initial value is given. Its initial value is given. Problem y dash is equals to f of x comma y on an interval I, if and only if, see this, the statement pattern is if and only if, okay, it is the solution of the integral equation y is equals to y naught plus integral from x naught to x f of t comma y dt on I. Means here what we have to prove? The solution of this differential equation, solution of this initial value problem f of x comma y on interval I, if and only if the solution of the integral equation x0 to x f of t comma y dt. That means we have to prove this result if some solution is exist for this initial value problem, then we have to show that that solution is satisfying this equation. That solution is the solution of integral equation. And suppose conversely, if there is a solution of that integral equation, then it is the solution of initial value problem. That means we have to prove this theorem in the both direction. This is called as a necessary condition and this is called as a sufficient condition. That means every theorem which is in the form of if and only if, that theorem we have to prove in the both direction, necessary condition and sufficient condition, or we can write conversely also. We can write conversely also. Okay. Now proof of this theorem. 1 minute. Now we shall discuss the proof of. लिहून कोणीच घेऊ नका रे students. Don't write with me because I am going too fast today, because lot of syllabus we have to cover in the today's lecture. So see this, suppose that phi is a solution of initial value problem on I. That means we have to consider phi is the solution of initial value problem. See this, phi is the solution of this initial value problem, then we have to prove that phi is also solution of the integral equation. And in second case we have to prove in the converse. Suppose phi is the solution of the initial value problem on I, and that initial value problem is y dash is equals to f of x comma y. See this, what is that initial value problem? Y dash is equals to f of x comma y. If phi is the solution of this initial value problem, see this, if phi is the solution of this initial value problem, then we can write phi satisfies the equation, so we can write phi dash of x is equals to f of t comma phi of t dt, because phi is the solution of initial value problems here. समजताय का पहा, initial value problem कोणता आहे? See this statement, y dash is equals to f of x comma y is called as initial value problem. Its integral equation is this. So suppose that first of all, in first case, in the necessary part, we have to suppose that phi is the solution of the initial value problem, that is y dash is equals to f of x comma y. So this solution can be written in the form of a function phi dash of x is equals to f of t comma phi of t, or we can also write f of x comma, याला असं पण लिहिता येतं f of x comma, so we can write, समजा आपण इथं t घेऊ किंवा x घेऊ, t घ्या किंवा x घ्या, कोणतेही एक घ्या. इकडे जर t घेतला तर इकडे पण t घ्या, किंवा इकडे जर x घेतला तर इकडे x घ्या, काय अडचण नाही. वी कॅन राईट दिस वे. समजा इथं t लिहा, कारण मी राईट साइडला t लिहिलेला आहे. इफ initial value problem is y is equals to y dash is equals to f of x comma y. If phi is a solution, then we can write phi dash of x is equals to f of x comma phi of x, or we can write phi dash of t is equals to f of t comma phi of t. In this way, there is no problem, we can write any term. So suppose that this is equation number 1. Suppose this is equation number 1. Students, लक्षात येतं का इथं solution असल्यामुळे equation satisfy होतं. You can write in the form of t or you can write in the form of x. Since phi is a continuous on I, since phi is a continuous on I and f is a continuous on a real number I, phi is a solution on interval I and f is a continuous on the real valued function, then the function capital F, there exists a function capital F defined by capital F of t is equals to, that means phi dash of t which is replaced by f of capital F of t which is equals to small f of t comma phi of t. Suppose this is equation number 2 and which is the solution of sphere and which is the solution of which is continuous on interval I. That means capital F is continuous on I. Now integrating this equation, if we integrating this equation from x0 to x, because we have to find the integral equation and we have to show that phi is also solution of this integral equation. So if we integrating this, then we get, see this, integrating this equation, integrating equation 1, phi of t चं इंटिग्रेशन घेतला तर काय येतं, पाय इंटिग्रेशन घेतल्यानंतर suppose with respect to x from x0 to x, then it will be phi of x which is equals to the initial value problem, that is phi of x naught means constant of integration. लक्षात घ्या इथं काय आलेलं असतं, y0 means it is the constant of integration. हा जो पार्ट असतो ना, see this part is also constant of integration and integration of this is integral from x0 to x f of t comma phi of t dt. But you know that the constant of integration which is obtained from the initial value, तुम्हाला माहित आहे जेव्हा जेव्हा आपण कॉन्स्टंट ऑफ इंटिग्रेशन कधीही काढत असतो तेव्हा इनिशियल व्हॅल्यू दिलेले असतात. According to the given initial values, we can find the constant of integration c and we can put this constant of integration in the given equation, then we will get the particular solution. So here phi of x actually which is denoted by the constant of integration in the form of initial value. You note that this, म्हणजे आता याचं इंटिग्रेशन घ्या, याचं इंटिग्रेशन घेतलं तर काय होतं पाय, मी इथं सांगतो. सी दिस, इंटिग्रेटिंग दिस, इंटिग्रेशन घेतल्यानंतर डेरिव्हेटिव्ह रिमूव्ह होतो phi of x. हे phi of x का, because we are taking the integration from x0 to x, so the terms which will be arrived is in the form of x. So डेरिव्हेटिव्ह रिमूव्ह होतो, इंटिग्रेशन phi of x. याचं इंटिग्रेशन घ्या, इंटिग्रल फ्रॉम x0 to x f of t comma phi of t. हे दोन्ही साइडचं इंटिग्रेशन घेतलं dt आणि इथं मात्र कॉन्स्टंट ऑफ इंटिग्रेशन c येतो. This constant of integration c can be obtained by using this initial value problem, initial condition, because everywhere the constant of integration can be obtained by putting the initial value. So this constant of integration which can be obtained by using the initial value, initial stage, so it is denoted by phi of x naught. This is the condition of initial condition. See this. So our equation becomes, after integrating equation 1, phi dash means derivative remove hoto, phi of x is equals to phi of x naught plus integral from x naught to x f of t comma phi of t. So we can write this. हे t आहे हा, थोडं चेंज करायचं. Okay. Now since phi of x naught is equals to y naught, but according to the initial condition phi of x naught is also denoted by y naught. This shows that phi is the solution of the integral equation. This आता phi of x naught means y naught लिहिल्यानंतर this shows that the phi of x is the solution of this integral equation 1. Now we have to discuss the converse part. Conversely means it is the sufficient part. If phi is a solution of this integral equation, then we have to prove that it is also solution of initial value problem. It is also solution of initial value problem. आता इनिशियल व्हॅल्यू प्रॉब्लेम मध्ये इथे एक द्यायचं राहिले पा थेरमच्या स्टेटमेंट मध्ये तुम्ही लिहा y ऑफ x नॉट, इथं लिहा रे, कॉमा देऊन इथे एक लिहा y ऑफ x नॉट इज इक्वल्स टू y नॉट. हे दिलेलंच आहे ऍक्च्युअली. इनिशियल व्हॅल्यू प्रॉब्लेम म्हणजे दिलेलाच असतो. कॉमा द्या. स्टुडंट थेरमच्या स्टेटमेंट मध्ये वाढवा y डॅश इज इक्वल्स टू f ऑफ x कॉमा y कॉमा y ऑफ x नॉट is equals to y naught. Actually this is a given condition, so we have replaced here phi of x naught which is equals to y naught. This is also given, since means it is a given, it is given, and this shows that the integral equation. तुम्ही ते थेरम मध्ये थोडं चेंज करा. थेरमच्या स्टेटमेंट मध्ये मला इनिशियल व्हॅल्यू प्रॉब्लेम y ऑफ x नॉट इज इक्वल्स टू y नॉट राहिलेला आहे. ओके, वाटलं तर इथं लिहू शकता तुम्ही इनिशियल व्हॅल्यू प्रॉब्लेम. एक स्टेप वाढवा इथं. इनिशियल व्हॅल्यू प्रॉब्लेम y डॅश इज इक्वल्स टू f ऑफ x comma y comma y naught. What is that initial condition? That is y of x naught is equals to y naught. इथं वाढवा वाटलं तर इनिशियल व्हॅल्यू प्रॉब्लेम इथं. ओके, y dash is equals to f of x comma y of x naught is equals to y naught. This is the initial value problem. Okay, no problem. Now conversely, suppose that if phi satisfies the integral equation 3 on I, phi satisfies the integral equation 3 on I, because हे इनिशियल व्हॅल्यू प्रॉब्लेम म्हटलं की इनिशियल कंडिशन दिलेलीच असते. See this, the initial value problem f y dash equals to f of x comma y. If this initial condition is given, then only we can say that it is initial value problem. दिलं तरच initial value problem होते. Oh, see this. Now conversely, suppose that phi satisfies the integral equation 3 on I, then if phi is the solution of integral equation suppose 3, then it satisfies the equation phi of x is equals to phi of x naught plus integral from x0 to x f of t comma phi of t dt. That means it is a solution, and also given that according to the initial condition y naught is equals to phi of x naught. Now differentiating this equation using the fundamental theorem, then we get, आता याचं जर डिफरन्शियल केला, डेरिव्हेटिव्ह घेतला त्या इक्वेशन 4 चं, तर phi of x चा डेरिव्हेटिव्ह येतो phi dash of x. See this, phi of x चा डेरिव्हेटिव्ह phi dash of x येतो. Now also the derivative of this constant term, because it is the initial value problem which is replaced by c. c म्हणजे कॉन्स्टंट टर्म असते, त्यामुळे याचा डेरिव्हेटिव्ह घेतला that will be 0. and परत आता याचा जर डेरिव्हेटिव्ह घेतला, याचा जर डेरिव्हेटिव्ह घेतला तर डेरिव्हेटिव्ह काय होत, इंटिग्रेशन आणि डेरिव्हेटिव्ह रिमूव्ह होतो, which is the function of the form f of x comma phi of x, which is the function of the form f of x comma phi of x. पहा खूप सिंपल आहे, काही अवघड नाही आहे. याचा जर तुम्ही डिफरन्शिएशन केलात ना, याचा जर डेरिव्हेटिव्ह घेतला तर phi चा डेरिव्हेटिव्ह phi डॅश होतो, कॉन्स्टंट ऑफ इंटिग्रेशन 0 होतं. हे डेरिव्हेटिव्ह घेतल्यामुळे इंटिग्रेशन रिमूव्ह होतं, इंटिग्रेशन फ्रॉम x0 to x असल्यामुळे दॅट विल बी f of x comma phi of x. As like a fundamental theorem of a calculus by putting the limits. Okay, simple आहे. So for all x in I, also from equation 4 it gives that phi of x naught is equals to y of x naught, and thus phi is the solution of initial value problem y dash is equals to f of x comma y and y of x naught equals to y naught. ये इनिशियल व्हॅल्यू प्रॉब्लेम म्हटलं की दोन्ही आलं लक्षात घ्या, डिफरन्शियल इक्वेशन आणि इनिशियल कंडिशन, अँड हेन्स प्रूव्ड. अशा पद्धतीने हे आपलं इथं प्रूफ होतो. हा थेरम सिंपल थेरम आहे, काहीच अवघड नाही. या थेरम मध्ये फक्त बोथ डायरेक्शन मध्ये तुम्हाला प्रूव्ह करायचे. यामध्ये एवढा पार्ट इथं ऍड करा, सपोज प्रूफ मध्ये ऍड करा हे. सपोज दॅट फाय is a solution of the initial value problem which is denoted by y dash is equals to f of x comma y comma under the condition y of x not is equals to y not on I, then we can write. मग याला आपल्याला असं रिप्लेस करता येतं. ओके, मग देअर एक्झिस्ट इनिशियल व्हॅल्यू प्रॉब्लेम, तो म्हणजे कॅपिटल एफ ऑफ टी असेल. पुन्हा त्याला इंटिग्रेटिंग घ्या, इक्वेशन 1चं इंटिग्रेशन घ्या. इंटिग्रेशन घेतल्यामुळे डेरिव्हेटिव्ह रिमूव्ह होतो आणि डेरिव्हेटिव्हचं इंटिग्रेशन घ्या म्हणजे इंटिग्रल इक्वेशन मिळतं. आणि अपोजिट मध्ये इंटिग्रल इक्वेशनला जर फाय ऑफ एक्स सोल्युशन करायचं तर त्याचा डेरिव्हेटिव्ह घ्या म्हणजे डिफरन्शियल इक्वेशन मिळतं. दिस इज द रफ आयडिया. ऍक्च्युअली दिस इज द रफ आयडिया टू प्रूव्ह दिस थेरम. हा जर थेरम तुम्हाला प्रूव्ह करायचा तर ही एक रफ आयडिया आहे. ओके, नाउ वी शॅल नोट, राइट डाउन दिस नोट. इफ phi of x is equals to y naught is the initial condition, then the first approximation is given by phi 1 of x is equals to y naught plus integral from x0 to x y naught. Phi 1 of x is equals to y naught plus integral from x0 to x f of t comma phi naught of t dt. So we can write y naught plus integral from x0 to x f of t comma y of t dt. Okay, so this is the solution of the differential first approximation of given problem. हा झाला first approximation. Y naught means actually phi naught of t. First approximation, because we have to solve this equation, each and every initial problem by using the approximation method. Okay, now next, 1 minute. Now we shall discuss second. The second approximation is given by phi 2 of x is equals to, how we have replaced this? Phi 2 of x is equals to y0. 1 minute. Second approximation is phi 2 of x is equals to y0 plus integral from x0 to x f of t comma phi of t. Means this is the second approximation which is obtained by replacing first approximation. This value of phi we have to replace here. Then we will get the first approximation. Then we will get the first approximation. Also in this way we can obtain the third approximation. Third approximation, how to get the third approximation? Phi 3 of x is equals to y0 plus integral from x naught to x f of t comma phi 2 of t dt. Means याच्यावरनं third approximation लिहू शकतो. In this way, in general, we can write k plus 1th approximation, that is solution by k plus 1th approximation means phi k plus 1 of x which is equals to y0 plus, this is the initial value, x0 to x f of t comma phi k of t dt. By using the solution of this integral equation, we can find the approximate solution. First approximate, second approximation, third approximation. In this way we can find the approximation solution series. लक्षात ठेवा हे solution आहे. Actually this is the first approximation. Phi 1 of x is equals to y0 plus integral from x0 to x f of t comma y0 of t. Okay, now we shall solve the problems based on this. आता याच्यावरचे आपल्याला प्रॉब्लेम सॉल्व करायचे. लिहून घेऊ नका, फक्त समजून घ्या आणि विचारलेल्या क्वेश्चनचा आन्सर द्या. रे प्रत्येकाने आन्सर द्या. आन्सर कुणी देत नाही, पहा मी पाहतो आन्सर कोण देतात काय नाही. इव्हॅल्युएट द इनिशियल व्हॅल्यू प्रॉब्लेम. Why we can say that this is initial value problem? Because we have given with the differential equation, with this differential equation y dash is equals to x comma y, we also given the initial condition y of x not is equals to 1. y of x naught is equals to 1 means actually at x0 is equals to 0 we have given y0 is equals to 1. शॉर्ट मध्ये दिलेले इनिशियल कंडिशन x naught y of x naught or it is also known as phi of x naught is equals to 1 means x naught is equals to 1 and phi naught of x is equals to y naught which is also given by 1 असं पण दिलेलं असतं. ठीक आहे. Okay, no problem. Evaluate this initial value problem. You can write here, evaluate the initial value problem. Evaluate the initial value problem y dash is equals to f of x comma y with the initial condition y of 0 is equals to 1. So given differential equation is y dash is equals to f x comma y and y of x naught is equals to 1. So y dash of f of x comma y dash of f of x comma y which is given by phi of x naught which is equals to y naught which is equals to 1. So we have given x naught is equals to 0. See this, phi of x naught, or it is also given that initial solution we can also write phi naught of x naught. Okay, no problem. The given differential equation is y dash is equals to, given initial value problem is y dash is equals to f x into y and y of x naught is equals to 1, that is y dash is equals to f of x comma y which is the function of x and y. Here phi of x naught which is equals to y naught which is equals to 1 and x naught is equals to 0. So we have the initial value problem. We can write the initial value problem in this way. So we can write the initial value problem y is equals to y naught plus integral from x0 to x f of t comma y naught into dt. The first approximation is given by, आता याचं फर्स्ट अप्रॉक्सिमेशन कसं येईल पहा. फर्स्ट अप्रॉक्सिमेशन घेत असताना पहा ॲक्च्युअली phi 1 of x is equals to y naught according to this first approximation. Phi 1 of x is equals to y naught plus integral from x0 to x f of t phi naught of t dt means here phi naught of t means 1. Function is f of x comma y means x into y. आता इथं y naught म्हणजे 1 आहे, इथं व्हॅल्यू y च्या जागी 1 ठेवा. दिलेला फंक्शन कोणता आहे x into y. We have to replace this x into y means x by t because we have to change this. So replace this x by t. See this, f of x comma y which is equals to x into y. मी डीप मध्ये सांगतो हे आलं कसं. How we get this step? I shall explain this. So f of t comma phi of t, f of t comma phi of t which can be written as t into phi of t. Y म्हणजेच phi of t. But we know that phi 0 of t is y0. So x into y naught means phi of t means y naught and y naught means x into 1. So sorry, in t into 1. T into 1. So this is the our integral. And also y naught, value of y naught is 1. Value of y naught is 1. So we can write this integral first approximation. हे कसं आलं लक्षात आलं का? दिलेला फंक्शन f of x, y is x into y. मग f of t,